Oh yeah. Okay, cool. So, hi everyone. My name is Zach. If you don't know me, I'm the developer at I2S, and I like playing with embedded stuff. So, what are we doing today? Um, we have this little audio signal processing project that we've been working on for the last few weeks. And I think the last time we worked on this, we got stuck because we had some memory synchronization issues. And I just checked it up. I just looked at the log, and I see we made an inference thread. And then from the inference thread, we wanted to, we made an inference thread that we needed to send data to from the audio thread. We can just explore this. So here it is. This is quite a mess, but we'll move this later. So we have an audio service, and our audio service right now, the audio service, forget all the filter stuff. We'll move this later. What our audio service does right now is I need to build this. Where's build NRF NRF52840 dongle, NRF52840, and then I want to do, this is actually a B. Let's do the dash B there, and then after dash B, I would like to do dash pristine. So let's actually just build it. Activate. So it's gonna be or do you want me to do that? Would you rather I do that? Okay, so let me see something, please. So from experience, if I open this here and I just go into my application itself, I should have I should not have the building errors, basically. Oh yeah, I do. So that doesn't help. So CD applications, Zephyr custom. I need to build this. Okay, let's remove that. Let's do that. Let's do control source. Source. I think it's Zephyr project, and then it's .env.n vn. Activate. Bin. Activate. Yeah, something like that. Cool. Yeah, awesome. So here we need to do a west build dash B NRF 52840 dongle, NRF 52840, and then dash pristine. Just do a clean build. I want to do a clean build so I can make an artifact, the compile commands file, and I'll put it in my root, and then this is a problem. Somehow I messed up my code in some weird way. Okay. Let's see, git diff, git status, and git branch. FIR implementation, and then I have an error, memslab free. Yeah. I don't see a problem here. I don't see where I'm getting this error from. Okay, cool. So kmemslab, did you mean kmemslab, kmemslab? This isn't the audio service. Why don't I have block size? do I just need to remove the whole build folder? I don't understand. Every time we try something new. -- pristine, yeah? Where's build board -- pristine? This should be okay. So I just came back to the project and it doesn't build. I'm quite confused. Config USB PID, USB device PID. I usually don't have those errors. Something is up. Okay, so let's first of all, let's actually just get something sort of sane working, and then we'll come back to this. CD samples, Zephyr samples, hello world, and then if I do this here, what do I get? Is there some sort of thing I need to do in order to build for the NRF dongle? Did I do so much FPGA stuff last week that I forgot NRF52840 dongle? Yeah, that is what I'm building for. But this is weird. Okay, this is weird. I usually don't get these. Why am I getting this? Subsys USB device make class. Why are you using that? What are you doing there? But I never. Why is this, why am I getting warnings from here? Yes, I was in USB yesterday. I was doing stuff in USB, but I shouldn't need this. I shouldn't need this. So let me see. Ah, I know. Oh my word. I'm in a different version of Zephyr. I promise you. Git branch. Yeah. So I was debugging. Okay. Good checkup, man. Okay, cool. So we fixed it. Git. Do I need any of those changes? Okay. Git stash. Dash m. Include untracked. Dash m IMX 219 UVC testing. Oh my word, I was nervous. I was so nervous. Okay, git status. Okay, git checkout main. I was so nervous. I can git pull. Yeah, cool. Just quickly go. Okay, clear. Okay, cool. So we're using a different Zephyr than. Okay, cool. This is fine. This is okay. That's a good way to start. Any questions so far? Just show them to me, and then as this builds, I should be able to get back to you. Yeah. Any questions so far? Just drop them into the comments, and I'm gonna just look at questions now while that builds. That should build just fine. Yeah, so I was on a different pull request because we were working on something over the weekend, and that's why. Hey Starless, how are you? Hey Bartholomew, how are you? Starless, welcome first of all. In the description of the video, there's going to be a link to our Discord community if you care to join and like all of us. Bartholomew is always there. He can answer a lot more questions. What we are going to do today is, I said his name already, but it's Bartholomew's favorite thing. We're going to compute an FFT signal for audio. An FFT computation of an audio signal. A real computation. Anyways, that's what I'm doing today. But it's generally, I'm going to be playing with Zephyr and audio and trying to find out more stuff about it. If you have any questions, please do ask. Don't worry about it. We'll answer them as best as we can. Yeah. Yes. Thank you. Thank you for the questions. Did I answer your question, Starless? Starless seems like a very odd name, but I think you're Starful. But let's see. Cool. That building is taking a while. Bartholomew, do you think we need to do... I should make it so that we can see comments. I really should somehow. Can I do stuff like that, and then rather than go that and go here? I mean, that's gonna be uncomfortable because you guys, or I can make it like this. It's not too bad, actually. This is not too bad. And then I can pop out the comment window here, pop out chart over here, bring it here, and then let's do this. The other thing I need to do, by the way, is to write a OBS plugin so that I can get the charts right in OBS and I can just put them in the video straight. But that's okay for now. And then in there, can I do like Control plus? Okay, cool. And then in here, can I basically do this a bit so it's smaller? Do we want... I know it's built, but let's try and figure out something here so that comments can be seen. Ah, come on, you bugger. And then here, yeah, we can put comments. Anyways, no, I'll leave comments on this side. That's a project for another day. Close that. Okay, cool. We'll figure it out on another day, but it will be good. So the first thing we need to do here is cp compile commands. Cp build compile commands to here. Okay, so we have compile commands, and the reason we're building that is so that when we open this, we would see the actual code that we needed to see without. Yes, so now it doesn't do the squiggly marks and say we're wrong, except on the first line, which is, I think, an NVIM issue, but we'll fix that another time. So, but let's now answer Starless's question. So we have an audio signal coming from our I2S mic into our microcontroller, okay? And this audio signal, eventually what we want to do is we want to apply filters to it because we like filters that much. But what we want to do is to apply DSP filters to the audio signal and then use that. However, in the last few weeks, Bartholomew and I have been working on this, and we've run into issues because whenever we try and apply our filter just after we've gotten our audio, which is here, just after we've gotten our audio, it takes too long, and the time scales drifts, and then we basically end up getting blocked. And I think I can run this version right now. I don't remember what the response from this version is, but I think I can run it. I need to do some stuff. I need to do a pack, Control R, and I think I need to do something like HW. Oof. Okay, cool. I can always get it from the Zephyr page here. and then we'll see what happens. So this is a command I'm looking for, basically this, and then I can put that here, and then I think that should be, oh come on, yeah, let's call that, and then we can call that FFT zip today. FFT, hopefully we get to doing an FFT. Yeah, this should actually work. This should work just fine. So cool. Yeah, there you go. And then I think I also need another command from here to just do the flashing. I'm gonna put this microcontroller on, and then I'm gonna put it in bootloader mode. Yeah, there's a red light. There's a bootloader mode. Okay, so let's flash it. And I think I can do 3 and then that, and then I can just, I want to do fft.zip. Yeah, and then Control Shift T, and then I need to do Control R, screen. Yeah, there's that one. But if I run it, it's gonna stop the flashing, which is not what we want. Okay, cool. Actually, there you go. So yeah. And our audio application actually needs us to connect to Bluetooth so that it allows the microphone to start recording. So I need to connect to Bluetooth to the device, and then that will trigger the microphone to start recording. Here it is. I'm gonna do this. Yeah. Connecting. Amazing. So it's actually doing it. But if you notice, it's actually, the app has already crashed, and it's crashing because this queue, this in FIR, let me see if I have files here. Okay, Control E, okay, and then I need to go inference service. Okay, amazing. So I have both of them. So in here, we need to clear this memory block. When we don't clear this memory block, what has happened here happens. So the app just dies. Basically, it runs out of memory and explodes. If we run it again, it will explode in a different way. But the point is, it just keeps exploding because we are not handling our queues correctly. And that's the first thing we're going to fix. I suspect it's rather easier to fix than I had anticipated, because I've thought about this for almost a week now, and I'm gonna do let's do some experimentation. So the first thing I want us to do is here. I want us to let's look at what is an RX block. So it's gonna be some sort of pointer. I'll put it as a log 1. That's not good. This is the pointer we should free. Okay, and then in here I'll just do something like P, I think so. And then in here I'll do like RX block. Okay, cool. And then I will do something like Control E, and then I'll go here, and then in here, what I want to do here, before we just put it there, what I want to do is I want to put in log 1, or even I can even use log R. That's just so we can see it. And then I'll say, come on, this happens on every stream. And then I'll say, this is the pointer we are sending. And then I'll do like P, and then I'll do that, and then I'll pass in info block. And the thing I want to do is I want to run that code. No, it's fine. This is okay. I can also just put this here. Yes, just so people can see the whole thing. When I use my big screen, it all visible, and I'm really zoomed in so that people can read, and that's fine. So what we want to do, I've done a log R, so Control E. Let's also use a log R on this side so that we can actually see both of them. So what I want us to do is just compare that we're using the same pointer, we're freeing the same pointer. That way we can actually make it work. Okay, and then okay, cool. Just let's move one at a time, and then we'll answer questions after I trigger the build right now. Any questions so far? I'm not so sure. But yes, actually, Bartholomew asked a good question. Bartholomew is asking a good question. He's asking, when we do this, when we get this line, should it really be no wait? And I think it should. The reason is this, you remember we added some semaphores? You remember we added some semaphores last week? And the reason it does this, and then you see it entered my capture. It left my capture, entered in firing. It's not double freeing for sure. I can see how a compiler would see it's double freeing, but it's not double freeing. If you walk through it slowly, you will realize it's not double freeing. But what I'm trying to show you right now, Bartholomew, first of all, or everyone, Bartholomew, thank you for the questions. You see, we have a state thing. You remember we have a state thing. We use the finite state machine, and we stopped. We made a semaphore stop the mic capture, and then we went into the inference thread. And if you remember correctly, because we have this, and because we are sending this signal, it can't be no wait, because by the time the inference thread is running at it, it's already filled. So there's no need of waiting. You shouldn't need to wait. But we can wait. We shouldn't need to wait. And then on double freeing, it's the same thing as, I can see how a compiler would see this as double freeing. It's the same problem we had do you remember the problem we had here, Bartholomew? With this case, memslab free. It looked like double freeing because actually the audio thread was allocating into here. So it looked like we were freeing something and we hadn't using it. But the point is when we hand it over to the I2S driver, it actually is it allocates it and it fills it, and then it's our responsibility to open it. And then we're doing the same between two of our threads. One of the threads, you have a fault from the MPU, not from from the memory protection unit, not from the compiler. Anyways, let's run this fast. It's easier. It's way easier to. I think this just built. Let's build it again. It's what is it saying is, so if you're watching this, there's a lot of comments going on right now from Bartholomew. I appreciate this very much. Bartholomew, where is the double free happening? Where does your MPU say double free is happening? I'm very interested to know. Okay, let's park this. No, it wouldn't work. So it's gonna work now. Okay, cool. I thought you meant MPU. I thought you were running the code on like some multiprocessor unit or something. Sorry. Okay, cool. So now, and then now I'll connect to it, and then let's see. What I would like to see is that the pointer is memslab with RX block inference slab. That's in the receiving thread. It could be. I agree with the memory protection unit there. It could be. That's in the inference thread. That's odd. We didn't get any logs. So save log, log, log. I agree. It could be. There could be a double free somewhere there. But I have a feeling it's because we're doing this. I really think this is a problem. I'll show you. I think this is a problem. Here's a problem. You see here, this should not be an address to an address. It should just be the address itself. This should be it. And I have a feeling if we do that, it should actually fix it. Let's see. How did I do that? No, I want to build it. Any more questions from other people? I have a feeling it's because we were sending an address of an address here. But the reason we were sending an address of an address here is because we were sending to the I2S thread, or rather I2S driver, and that would fill the thing here for us. But between our own threads, we don't have to do that, so we can just send this one, and on the other side it should work. Let's see. I would love to figure it out, and I would love it if you know, something could point us to the thing and we could fix it. Any more questions while we try and figure this out with Bartholomew? Thank you, Bartholomew. I really think it's the way we're freeing it. So that RX block should be, right now, the right one. But this is also odd. We never got any log errors. We should get log errors because we need to get this. It should say the pointer we want to, basically. And this message should point. This message should point to the same. This message should point to the same message pointer that this points at. Then we know on both sides it's the same thing. I think that's where our synchronization issue came from. I need to get a ARM mark or an ARM thing so that I can build this faster, man. The builds take so long. I'm thinking of doing something where I can write code on my machine but build it on a Raspberry Pi and then flash from the Raspberry Pi, but I don't know. We'll see about that. First of all, we need to packet. So that makes a build.fft.zip for us. And then I need to put the device in bootloader mode. And then after that, we need to flash it. This might actually fix it. Hopefully, this might actually fix it. Yeah, we can put it on now. It's on. Let's start the recording. By connecting. Connect. Much better. But why are we not seeing why do we never see this? Why do we never see this? Why do we never see this? This is good. These are good pointers. That's fine. When we enter inference, and it says inference has been run, it runs this line. Why do we never see this? This is a problem. Why do we never see that? So it goes enter mic capture, sending audio, sending audio, go to inference state, to the left mic capture. That's cool. Inference has been run. Why? We see this, so this is done. And do we give the inference gate? Yeah, sure. But how come this is never run? Okay, this is a problem. How come we never get to that line? Oh my word. Thank you, Bartholomew. Yes, I genuinely thought it was, I genuinely thought it was the same thing. So it works. So it works. They're the same now. It works. We fixed the issue. Should we also give the, I think we fixed it. Should we also give the, should we also give the should we exit the state here? Let's exit the state so that I have to think. So let's exit the state. Let's fix it so that it can go back. So let's exit this state. Let's send a signal that allows us to leave inference. And whenever we leave inference, then that means audio can be activated again. So that way we can see it rolling over many times. It worked. Yes, it worked. So not a double free, Bartholomew. Let's send a signal here to leave inference. And then we want to go to the FSM. I do want to do FSM service.h. Do we, which inference end, inference start, inference end, audio sounds end, audio sounds start. So we need to send this signal. We need to send this signal, and whenever we send this signal, first of all, we need to send the signal. But whenever we send this signal, we need to it's never what I planned for it to be. It's never what I planned for it to be. So now it looks like we're gonna do some state machine stuff instead of the FFT. But you need to do these things in order so that they work. So what I'm seeing here is in inference. Where is inference? Entered my capture audio sense and yeah, that's cool. My capture exit. So this is it. Here we need to receive a signal here like this one, so that when inference ends, we actually enter, we go back to connected probably. And if we do go back to connected, when we go back to connected, we should give this gate. You see, if we give this gate, then mic sense can happen, and then it can be always looping. I'm so relieved. We fixed such a huge thing. The problem is like maybe just me and Bartholomew know what we fixed. We fixed such a big problem that we've been facing for so long, and it's like it's just sort of confused me because it just sort of worked. Yeah. Any questions so far? Any questions from anyone? Okay. So first thing I want to do is go to the audio thread and see how events are sent, because I don't remember. Sorry. I want come here and I see what events are sent. Yeah. So we need to do this Y. And then I need to go to the inference service, and in here what I want to do is after I've given that gate, I want to do this. Yeah, what I want to do here is sorry about that. What I want to do here is post the event. I think event sends event. What is this? What event do I want? Inference end. Yeah. So that's the first event I want to post, inference end. And then if we want to go back to our FSM service here, we want to go back to the connected mode. And I'll just copy this because it just sort of works. It works. So I'll just use it. Inference, yeah. So here, I can always remove that. I don't need to set state. Let's do this. If the event is inference end, what I want to do here, if I get here, go to connected state. So I want to go back to connected state. Connected state. So I want to go back to connected. However, when I get into connected, there's some work I do when I get into connected. Let's see. When we enter connected, we allow mic sense to happen. So that should actually re-trigger our mic sense to happen, and then the semaphore should allow the mic thread to actually record. So let's see if we can get rolling records instead of like one single shot like this. This is amazing. It works. I'm shocked. Bartholomew, aren't you shocked? Or did you just expect it? Because Bartholomew knows everything, so when he says it works immediately. Okay, while that is building, this is what we need to do. This is now the next step. So the audio that we are getting is a real signal. What we need to do, what I want to do is I'm going to be applying filters to it. I'm going to be trying to do things like MFCC. By the way, people, did you know this? Bartholomew, did you know this? Did you know you can do this with did you know you can do this? Look at that transform function, MFCC. You can do audio keyword spotting from Kimsys DSP. Do you even need I guess you need a model. You need to train your model by yourself on the other side and run the coefficients into a model later. But that's half of the way there. If you can sample your audio and do MFCC already, that's half of the way to Hey Siri. Not you. But think about it. I didn't know that. I didn't know I could do that here. What the heck? It's like the world is free, man. Okay, cool. I didn't know. Okay, so let's see. Let's see if yeah, that's Packet FFT. And then let me put this thing in bootloader mode. And then let's see some magic happening. Bartholomew, I did not know I could use Kimsys DSP. Although it does say in the name, and although one of the other things that we can access from Kimsys is neural network stuff. So, what do you need? Oh, how do I get there? So Kimsys also has a neural network. And if you have a neural network implementation or a NPU on your device, you can just do everything. It's all free. Okay, cool. So that's programmed. I'm getting carried away. Cool. Please roll over without dying. It just works. It works. It's going. It's not stopping. Wow. I'm impressed. I'm impressed. Let's write some comments, man. Let's write some comments. This is too good of a state to not write some comments. Git status. Git add audio service. Audio service. What is an audio service? Git diff src audio. Okay, cool. I don't actually need to log that. We can leave it in for a while, and then later we'll like disable logging completely. So for now we need it. For now, do I need it? Do we want it there? I don't think we need it because it's gonna be noisy. So cool. So let's actually just remove that logger because it works now, and we know it works. Okay, fine. And then also in the FSM service, but I bet. So in the no, not in the FSM service, in the inference service, let's remove the log as well because it's gonna be noisy. We're gonna do more stuff, and it's gonna make everything more noisy. So this we now know this is working. We now know this is working. Thank you for printf, man. Thank you for printf. Git status. Git add src audio. Git add src inference. Git diff -- stage. Actually, we can't just go back and do. We can run the FIR implementation now. Yes. Git diff staged. We'll look at it. We'll look at it for sure. We'll look at it. Okay. Git commit -- m. Git commit m. This is going to be inference. Let's say clear, correct, memblock, and signal inference, and git status, git add src fsm, git diff -- staged, git commit -m. This is also inference handle inference and signal. Our state machine is still a mess. There's still a lot of loopholes. There's still a lot of like sieves where things can fall through and stuff. So we need to fix that later. But as we go through it, we'll fix it. This that becomes like a certification thing. Which, are we gonna do certification? I don't think so. What are we building even? Okay, cool. Okay, cool. I mean, we can just activate this. We can activate this and see what happens. Bartholomew, shall we activate this and see what happens? Maybe we should just activate this and see if we can get a FIR filter out of it, just for giggles, and see if we can do it actually. So that should be X U Y. So here we normalize the symbols here. We're gonna normalize SP top. Sorry, there's probably easier ways of doing this, but it's easier to just go through everything at once. Here, and then I can just use RX block here. RX block. Okay, cool. And I remember that samples F, so it's fine. You can just call it samples F if you want. That should be cool. And then no. This is wrong. So I get samples. I cast RX block into samples, and then from here I need to get samples themselves and do stuff with the samples. Samples per block, that's fine. F++, that's fine. So I need a samples F as well. So I need a. This is not cool, but I need a samples F. Where is samples defined? And no. This is not even a samples F. This is a. I just walked into some gnarly stuff. I know what is happening here. So we go to audio service. Now all of this stuff needs to start moving to the other side basically. So we want this float samples and filtered samples. We actually need all of this in the other side. So this all needs to go to the other side because this is all like filtering stuff that we need to use on the other side. And we made filters. We should use them, yeah. So in FIR service, let's define them here. I know we need some sort of import. I know we need some sort of import for the float 32s to work. In FIR block add, that's fine. Do we ever use this? In FIR block add. Who uses you? Who uses you? In FIR block. Where do we initialize the K50? confused. I think that's some leftover code from something else. Okay, FIFO, Zephyr. What's up? What do you need? Jan wants to say hi, people. Oh yeah, you can come up. I'm right here. Why does our code work and we're not using the inference block? Yeah, seriously, little lady. Don't sit on my computer. I think it should work. I don't think we need it because this is the data that we're putting in the data that we're putting in the FIFO is like super simple. This is Jan. Jan needs to be involved in the streams. She loves the streams. This is bad because something works and we don't know why it works. That's not a good state to be in. And I can see here we use TX data, but this never becomes in FAR thing. And I think that means that the code we have up here is, no, don't go there. You're gonna spill tea over things. Please, you're just walking on cameras and things. I'm sorry. I'm really sorry. I'm not trying to be mean to the cat. I feel like this should still work. I really think that should still work. So if it doesn't work, we'll just put it back. We have commits. That's why we have commits. So let's just put this on the other side. Okay. So there's some stuff we need to bring in here. Yeah. We don't need air and math here anymore. Cool, that works. That works. FIR state. What do you mean? What's the problem here? You never used. Okay, that's okay. That's okay. You never used. So that's fine. So now we can go back and start doing this stuff. Yeah. That now works. And then we need to filter the samples. So we've done the normalization now. Let's actually do the filtering, and then we'll do an FFT if we have time still. So that ends normalization. That means and then I just want to remove this, and then oh my word, little lady, what do you want? What do you want, Jan? Okay, so I want to remove this. I want to remove this SV. No. X. And then I'll go back here and we said do filter samples. I just want to filter them here for now. Let's filter them and see what happens. I know, I kind of sort of know where that issue is coming from, but I have an idea. But let's actually just make our code all organized. And I know I can use some Vim food to do this all at once, but that's not that I haven't done right now. I know I need to instantiate that filter somehow, and I expect I was instantiating it here. I think I'm gonna do an X W E, and then I'm gonna go back to the inference service, and then before when this thread runs the first time, I'm gonna something of sort so that it goes there. Unfortunately, I'm gonna run out of time today, so might not even get to the FFT, but that's okay. A lot of things have worked, so we don't even have to get to the FFT. A lot of things have worked, to be honest. Any questions so far, by the way? Any questions by anyone? This is me trying to fix decisions that have come about through weeks of work, so please. Okay, let's run an FIR filter and then see if actually that works. That's a good thing, because we can just, let's run an FIR filter on the time domain and then maybe see if we can convert it to, who are you? Okay. There's two of them. Yin is somewhere here. Sometimes she likes getting involved. Yeah, let's see if we can run this before we actually go on. Does it still build? You're sitting on my laptop. You can't. I mean, my computer. You can't sit on that. You can't sit on my keyboard. I know what you're gonna do. You're not allowed. You're not allowed. You're not allowed. You ate the other day you ate headphones, so you're not allowed near wires. You can't. You can't. You're not allowed to go there. Can you please? No. Let's see if this works. We're going to something else. See if this works. Let's see if this works. Am I allowed to work? What is this now? That's your sister. Okay, so it builds. So that's sort of a good sign. Let's actually see if we can control R dash dash HW. Yeah, can we packet? That's fine. Control R DFU. Okay. Send it out to the device. Ideally, we should see a filter running and get some sort of like output from it, which is going to be good. It didn't crash. That's a good sign. That's a very good sign. Connect. Raven. So I'm so happy. I'm insanely ecstatic. This is insane. And they're all different, so it actually is working. It's like real world signals. It is working. Yeah, they're all different. Oh my word. Oh my word. So we got an FIR filter going through. An FIR filter is already going through. And our filter is... Sorry, I'm going to make noise because our filter is for claps. It's working. You can see them coming through. I think so. Bartholomew, is this working? Bartholomew needs to be the judge. Is this working? We ended up with an FIR filter, not an FFT filter. Well, FFT is not a filter. It's just a computation. It's a transform. Any questions so far from the people around? Any questions so far? I'm just amazed that it's working. And anyways, yeah. Bartholomew says yes, it works. So it does work. It actually does, because look at what happened. Look at the last signal when I clap. I'm gonna clap a bit. It's gonna be loud, I'm sorry. But look at the last signal. You'll see that it actually... Look at that. There are like thousands in the last one. It's seeing them. It's filtering. Oh my word. Oh, okay, cool. Bartholomew, I'm going to stop now. I'm going to stop now and I'm going to push the code up. I'm going to stop now and I'm going to push the code up. And then you can probably pull it. There's a few changes you might want. So let's stop this. Let's stop this, and we didn't manage to compute the FFT signal. The reason is we managed to debug our FIR signal and our FIR filter and get it working. So probably we can do a part 2 of the FFT signal where we know everything is working and we can jump this into a working state. It's anyways been an hour. I've got a lot of work that I have to jump into, so I'm going to have to stop now. I'm going to commit this because I know Bartholomew also wants to try it, and I can give him this state of code so that he can use it. Any other people with any questions right now so far? Git status. Vanad's here. Need add. Get yeah, get diff. So we removed all the inference and we moved all the inference to inferencing. That's really what we did, and we did an FIR filter on the other side. Git add, git commit -m move filtering to inferencing and run it there. That's it. Git status, git push, and that should be up. That should be up. If anyone wants to try out this code, it's on GitHub. I think it's on Zach probably. Wait, let's see. Maybe it's on Zach, maybe it's on Gaucho's custom BLE service. There's a custom BLE service here. The code that we just worked on today is on the second pull request. This one that says add a FIR implementation. We actually added a working FIR implementation. That's it. We got it in. We're done. Bob's your uncle. Where's the money? I have way too much fun doing this stuff. I have way too much fun learning like this. Bartholomew, here's the code. You can try it now. So maybe you don't get MPU faults. And if you do get MPU faults, can you please open an issue so that we can debug that? And for everyone, who showed up and stayed up through the hour. Thank you so much for showing up. Leave any comments or questions, or send me a message. There's a Discord in the video description. Join us, and yeah, let us learn together. Ask questions, try stuff, break things, push broken code. And remember, rather than building new stuff, just go fix the things that are broken. It's like free money, man. Cheers. Thank you everyone so much. That was a lovely hour. Bye. Hey Jimbo, thank you so much. Thank you. That was a lovely hour.